In 2013, in the Rhodope Mountains of southern Bulgaria, two archaeologists surveying a Thracian burial site nearly walked past a slab of stone half buried near the tomb entrance. It wasn't ornate. It wasn't inscribed with any language. What it had instead was a pattern of small, deliberate holes, drilled into the surface with a precision that immediately caught their attention. Within days, they realized what they were looking at: a map of the night sky, carved roughly 5,000 years ago, decades before the first pyramid at Giza was even planned. That on its own would already be remarkable. Early humans, recording constellations we'd still recognize today, in stone that's outlasted the empires that came after it. But the detail that turned this from an interesting find into something researchers are still quietly arguing about is this: one of the points on that map, positioned exactly where the ancient sky's fixed center should be, doesn't correspond to any star currently occupying that position. The star it was built around isn't there anymore, at least not where it used to be. And the reason why says something about how much confidence we should really have in a sky we assume never changes. The stone itself is unassuming, roughly the size of a car door, flat, gray, weathered on one edge from thousands of years of exposure before it was ever buried. The researchers who found it, Georgy Georgiev and Evelina Georgieva, weren't even looking for it. They were documenting a known Thracian necropolis nearby when Georgiev noticed the pattern of holes catching light at an angle that made them look intentional rather than accidental erosion. That distinction matters more than it sounds. Stone weathers randomly. Wind and water don't produce clusters of holes with consistent depth and spacing. What they'd found had neither the randomness of natural decay nor the crude look of casual etching. Each hole had been drilled to a specific size, at a specific point, and the whole arrangement ran along a clean east-west axis, which is not a detail you get by accident. Dating placed the carving at approximately 5,000 years old, based on its association with the surrounding burial site and the geological context of the stone itself. That timeline puts it well before Stonehenge reached its final form, and centuries before Egypt's Old Kingdom began raising its own monuments to the sky. Whoever carved this wasn't experimenting. They were recording something they'd already spent a long time watching. Once the pattern was documented properly, astronomers were brought in to see whether the layout matched anything real, rather than being a striking but meaningless arrangement. It did. Several of the clusters lined up convincingly with constellations still visible from that same latitude today. A tight, angular group corresponds to Ursa Major. Another, more scattered pattern lines up with Cassiopeia. There are indications of Cygnus, the swan, and a dense cluster of tiny, closely spaced holes that maps almost exactly onto the Pleiades, the seven-star cluster that shows up in the mythology of nearly every ancient culture that left written records. Then there's the detail that convinced most of the skeptics. Running diagonally across the stone is a natural vein of white marble, cutting through the darker rock. It isn't carved. It's a feature of the stone itself. But its position, running through the middle of the star pattern, lines up almost perfectly with where the Milky Way would have appeared in the sky at that time and location. Whether that alignment was recognized and deliberately incorporated, or whether the carvers simply chose a stone whose natural markings happened to suit their purpose, is something we can't fully answer. But either way, what they built wasn't decoration. It was a working record, accurate enough that people using modern star mapping software can still line it up against the real sky. Here's where the map stops being simply impressive and starts being genuinely strange. Among the drilled points, there's one that sits apart from the rest, isolated near what would have been true north relative to the other markings. Its placement is deliberate. Every other hole clusters into recognizable shapes. This one doesn't belong to any of them. It stands alone, in the position a fixed reference point would occupy, the kind of marker you'd use if you needed a stable anchor to orient everything else around. That's exactly how ancient astronomers, across almost every culture we have records for, treated the star nearest the celestial pole, not just as one point among thousands, but as the anchor. The one position in the sky that appeared not to move while everything else rotated slowly around it, night after night, season after season. The problem is straightforward. Point a modern telescope, or even just a phone's star tracking app, at that exact coordinate today, and you won't find a star holding that role. Polaris, the star we currently call the North Star, sits close, but not close enough to explain a marker this precise. Whatever the carvers were anchoring their entire map around, it isn't sitting where they left it. To understand what happened, you have to set aside the assumption most people carry without ever questioning it, that the North Star is a fixed feature of the sky, the same for every generation that's ever looked up. It isn't. Earth doesn't just spin on its axis. That axis wobbles slowly, tracing a wide circle over a period of roughly 26,000 years. The way a spinning top wobbles as it loses momentum, just at a pace too slow for any single human life to notice directly. Astronomers call this precession, and its effect on the night sky is enormous once you account for enough time. The point in space our axis happens to be pointing toward doesn't stay fixed on one star. It sweeps slowly across a whole circuit of them, decade by decade, century by century. The star that holds the title of North Star today is really just whichever star happens to be nearest that point at this particular moment in a 26,000-year cycle. 5,000 years ago, when that stone in Bulgaria was being carved, the axis was pointing somewhere else entirely. Somewhere close to a star most people today have never heard of, one that hasn't held the job of anchoring the sky in over 3,000 years, and has quietly drifted into astronomical obscurity ever since. That star is called Thuban, a modest point of light in the constellation Draco. It isn't particularly bright. On a clear night, most people scanning the sky wouldn't single it out from the surrounding clutter of stars. But around 2800 BCE, Thuban sat within a fraction of a degree of true celestial north, closer to the pole than Polaris manages today. For the civilizations building some of their most ambitious monuments during that exact window, Thuban wasn't a footnote. It was the fixed point everything else in the sky appeared to rotate around. The evidence for how seriously it was taken isn't limited to star maps carved into stone. Egypt's Great Pyramid includes a narrow descending passage, angled with a precision that has puzzled engineers for centuries. And that passage points directly at the patch of sky where Thuban would have hung, low and constant, above the northern horizon. It's difficult to look at that alignment and conclude it happened by chance. Then slowly, over the following centuries, precession did what it always does. Thuban drifted from the pole. The role passed to a fainter star called Kochab for a long stretch, then eventually settled on the star we rely on now, Polaris, sometime around the early centuries CE. Thuban didn't explode. It didn't vanish from the universe. It's still there tonight, if you know exactly where to look for it. What it lost wasn't its existence. It lost the one thing that made an entire civilization build their most sacred architecture around it. This is the part worth sitting with, because it reframes the entire premise of that stone map. The star is missing in exactly one sense, and it's not the dramatic one. It didn't burn out. It didn't collapse or disappear from the galaxy. What vanished was its authority, the specific temporary alignment that made it the sky's anchor point for people living through a narrow window of a much longer cycle. That distinction matters, because it tells you something about the people who carved that stone. They weren't just sketching whatever happened to be overhead on a clear night. They were recording a structural relationship, a hierarchy in the sky, with one star at the center holding a position the rest of the pattern depended on. Losing that context is exactly why the map looks slightly wrong to us now. We're reading it with the wrong star already installed as the anchor in our heads, without realizing the sky itself has quietly rotated the cast since then. It's less a mystery than a translation problem. And once you translate it correctly, the stone stops looking strange and starts looking like exactly what it always was: accurate. If precession feels too slow and abstract to fully register, there's a more recent example that makes the same point on a timeline you can actually observe within your own lifetime. Late in 2019, professional and amateur astronomers alike started noticing something wrong with Orion. Specifically with Betelgeuse, the bright red star marking the hunter's shoulder, one of the most recognizable points in the entire winter sky. It was dimming, not subtly. By February 2020, Betelgeuse had lost roughly 2/3 of its usual brightness, a change stark enough that people with zero astronomy background were noticing the constellation looked off, even if they couldn't say exactly why. For a few tense months, there was serious speculation that one of the closest supergiant stars to Earth might be approaching the final stages before a supernova, an event that hasn't been directly observed in our galaxy since the 17th century. The Hubble Space Telescope and ground-based observatories eventually settled the question. Betelgeuse had ejected an enormous cloud of superheated material from its surface, which cooled into dust and temporarily blocked a portion of the star's light from reaching us. By April 2020, the star had recovered. It wasn't the death of a star, but it was proof, witnessed in real time by anyone who bothered to look up, that the sky isn't the static backdrop most of us assume it is. Stars change, sometimes slowly, over thousands of years, the way Thuban did, sometimes fast enough to notice from your backyard in a single season. Put those two things side by side, and the people who carved that stone in Bulgaria start to look very different from the way prehistoric societies usually get portrayed. Not primitive, not superstitious. Patient, methodical observers, tracking a sky they clearly understood was worth recording accurately. Using nothing but their eyes and generations of accumulated attention, there's no evidence they understood precession the way we do now. No reason to think they knew their anchor star's reign was temporary. But they didn't need to. What they left behind is, in its own way, more impressive than a prediction would have been. It's a precise dated snapshot, a fixed record of exactly how the sky looked from one specific place, at one specific moment, 5,000 years before anyone had the mathematics to explain why it wouldn't stay that way. That's what makes stones like this genuinely valuable to modern astronomy, beyond their novelty. They're not myths dressed up as science. They're data points, physical testable claims about the position of specific stars at a specific point in the past, left by people with no way of knowing that we'd eventually have the tools to check their work and confirm they got it right. So the star that's missing from that carving was never really gone. It's still up there tonight, quietly demoted, holding no particular significance to anyone scanning the sky without knowing its history. What's actually missing is a 5,000-year-old arrangement, a sky that existed exactly once, briefly, and will never line up in quite that configuration again. Which raises the obvious, slightly unsettling question. Every star map we make now, every coordinate we treat as fixed, every north we build our own instruments and monuments around, is doing precisely the same thing that stone in Bulgaria did, recording a moment, not a permanent truth. Somewhere around 10,000 years from now, long after Polaris has quietly stepped down and handed the role to something else entirely, someone might find a record we left behind. And they'll have to do exactly what we just did. Work out which star we meant. Because by then, it won't be there either. Not gone. Just once again, somewhere else.